how do we solve for x and y in this logarithmic equation? So let's call this equation 1 and this equation 2. So now from equation 1, we just take the natural logarithm of both sides. So we have log 3x raised to power log 3 equals log 4y raised to power log 4. So we are going to apply rules of logarithm here. That is, whenever we have log a raised to power b is the same thing as b log a. So this implies log 3 times log 3x equals log 4 times log 4y using this property. So this implies log 3. But log 3x can be written as log 3 plus log x. By applying this property, the product rules of logarithm, that whenever we have log ab is the same thing as log a plus log b. So equals log 4. Log 4y also we can write it as log 4 plus log y. So now let's open this bracket. So this is log 3, sorry. Log 3 times log 3, that gives log 3 all square plus log 3 times log x, that's log 3 log x. So log 4 times log 4 gives log 4 all square plus log 4 times log y. So now let's call this equation 3. Let's call this equation 3. So from equation 2 also, from 2. So we take natural logarithm of both sides, so we have log 4 raised to power log x equals log 3 raised to power log y. So this implies log x log 4 equals log y times log 3. Applying this property. So let's call this equation equation 4. But we can write this guy as log x equals log y log 3 over log 4. That is, when we divide both sides by log 4. So let's just call this equation 4. Now we are going to substitute equation 4 into equation 3. Sub 4 into 3. So we have, so anyway we see log x, we just replace it by this. So we have log 3 all square plus log 3 into this guy log y log 3 over log 4. Bracket close equals to log 4 all square plus log 4 times log y. So this implies, let's open this bracket, that is, we have log 3 all square plus log 3 times this. No, we have one log 3 here, so we have log 3 all square log y over log 4 equals log 4 all square plus log 4 times log y. So we are going to isolate the common terms. So we have log y here, we have log y here. Let's put it on the left side. So we have log 3 all square log y over log 4 minus, when this guy comes to the left, log 4 log y equals, so now this guy we have log 4 all square. When this guy comes to the right, we have minus log 3 all square. So let's take the LCM here. The LCM here is log 4. So when we do that, we have log 4. So this guy log 4 cancels log 4. That's 1 times this. We have log 3 all square log y minus log 4 times this. So we have log 4 all square times log y, which is simply equals to log 4 all square minus log 3 all square. So log y is common here, so we are going to pull it out. So we have log y into log 3 all square minus log 4 all square, everything over log 4, which is equals to log 4 all square minus log 3 all square. So now we use this whole guy to divide both sides. So when we do that, we are going to obtain log y equals log 4 all square minus log 3 all square divided by this guy, which is log 3 all square minus log 4, everything all square, divided by log 4. So this implies log y equals, don't forget this is just 1 at the denominator, so we have log 4 all square minus log 3 square times log 4, because division will change to multiplication when this guy goes up. So we have log 3 all square minus log 4 all square. We'll observe that we can adjust this guy. So we have log 4 all square minus log 3 all square times log 4 over, by writing it as this denominator as minus into log 4 all square minus log 3 all square, practically, because minus times log 4 gives minus log 4 all square. Minus times minus gives positive, so we are good to go. So in this case, this is log y on the left. So in this case, this cancels this. So we are left with log y equals minus log 4. There is y here, log y equals minus log 4. So now, this can be written as, this implies log y equals log 4 raised to power minus 1 by rules of logarithm. So when we take the exponential of both sides, let's say we have exponential of log y equals exponential log 4 raised to power minus 1. So this exponential acts as identity. So this implies that y equals to 4 raised to power minus 1, which is the same thing as y equals to 1 over 4. So this is the value of y. Now, to obtain the value of x, just plug in the value of y into equation 4. So let's write it here, sorry, and just manage here. So our value of y is 1 over 4. We are going to plug it here. So we have log x equals log y now will be log 1 over 4. So we have log 1 over 4 times log 3 over log 4. So this implies log x. Don't forget log 1 over 4 is the same thing as log 4 raised to power minus 1 times log 3 over log 4. Just guide this. So this implies log x equals log 4 raised to power minus 1 is the same thing as minus log 4 log 3 over log 4. So in this case, we have log x to be equals log 4 cancels log 4. So we are left with minus log 3. Minus log 3, which implies log x equals log 3 raised to power minus 1, like we did earlier. So now, we take the exponential of both sides. So we have exponential of log x equals exponential of log 3 raised to power minus 1. And in this case, exponential of log will act as an identity. For that, we have x equals to 3 raised to power minus 1. So this implies that x equals 1 over 3. So this is the value of x that is required, and y equals to 1 over 4. So that's it.